Hi everyone. So please welcome back in my today's session. And in this session, I'm going to start one more new method of the analytic function, and in this method will be the last one of this particular topic. And actual this method is basically included with the analytic function only, and still one more method is remaining to complete this first unit. Okay. So let's start guys, and before starting, in the previous sessions we have just completed harmonic functions, right? So hope you all did very well guys. So let's start with our today's topic, and the name of the topic is given the constructions of analytic functions, and it's the method name is given Milne's theorem method. So this one is very much easiest method, and this one probably it will be come into the 7 max. So please do carefully guys. Okay, so here you can see that there is given case 1, so there are total 2 cases. Okay, and first case is for the real part, and the second case is given for the imaginary part, and I'm highlighting guys, this is for the real part, and the second case will be for the imaginary part. So it depends on the equation, whatever whether it's given into the imaginary, yani ki into the v form, the values of the function will be given into the v form, then we will apply case 2. And if the value of the function will given into the u form, then we will apply real parts. Okay, so in the case 1, if the real part u of f of z is given, यानी कि आपको क्वेश्चन में क्या दिया होगा, u equals to, it will be given sum of the functions. Okay, again repeating guys, in the equations it will be given like u equals to sum of the function of the z or xyz. Okay, so in the at that time you have to apply step 1, as you have to find del u by del x and del u by del y. So in the very first step you have to find del u by del x and del u by del y. Okay, now in this step 2 you have to find f dash of z equals to del u by del x plus I del v by del x. As you know all guys, what will be f of z? I am writing here one more time here, because previously already I have written into the slides, but this time also I am writing f of z. It's nothing but u plus iv. Hope you are uh, seeing properly. Uh, Let me correct. So f of z will be u plus iv. So the f dash z will definitely, it will be del u by del x plus I del v by del x, as we are doing with respect to x form. And if we will do with respect to y form, then it will be del u by del y plus I del v by del y. Okay, so right now we are just doing with respect to x, and we will do with respect to x only. Okay, now you have to apply CR conditions. Okay, so in place of dv by dx, I am using CR conditions. So CR, you all having two CR conditions. I am speaking orally, so please listen carefully. Ux equals to vy, यानी कि del u by del x equals to del v by del y. Okay, and the another will be del u by del y equals to minus del v by del x. Okay, so here it's given del v by del x, so it will be the negative of del u by del y, so that's why I have written here minus del I del u by del y. Okay, so in place of this del v by del x, I'm going to apply del u by del y, and this is by using the CR conditions. Now in the third step you have to put, in place of x you have to put z, and in place of y you will put 0. and that will be you will apply into the f dash z form, यानी कि जो आपने ऑलरेडी सेकेंड स्टेप में फाइंड किया होगा, राइट, उसी में आपको अप्लाई करना है x इक्वल्स टू z and the y equals to 0 value. Okay, and at the last in the fourth step you have to integrate the that particular term, यानी कि f dash z को आपको क्या करना है, उसका इंटीग्रेशन करना है, and that after doing the integration you will get final term as an f of z form. Okay, so this will be your last final step. So hope you all understood very well, guys. Now it's given case 2, and as I have said in our previous slides that in the second case we will apply for the imaginary parts. It means into the equation it will be given in the form of v form, right? So if the imaginary part v of f of z is given, then you have to apply here. Case 2 will be for imaginary part and for the v will be your equation, यानी कि equation में आपको v का कोई function दिया होगा, ठीक है. So it will be given by the step 1. Okay, so in this step 1 you have to find del v by del x and del v by del y, as v will be given into the equation. So that's why we will find here v with respect to x as well as v with respect to y. Now step 2, again as it is, you have to apply f dash of z, and definitely it will be del u by del x plus I del v by del x. And now again you have to apply CR conditions, but in place of del u by del x, now we will apply del v by del y. Okay, so by using CR conditions, again repeating, you all having two CR conditions. First one is del u by del x equals to del v by del y, right, यानी कि ux equals to vy. So वैसा ही हम लोगों ने इधर अप्लाई किया है, आप लोग देख सकते हैं that ux equals to vy मैंने अप्लाई किया है, right, or this one will be as it is. Now in this third and fourth step will be same. So in this third step you will put x equals to z and y equals to 0, that is into the f dash z form, and at the last you have to integrate this function only, यानी कि f dash z को ही आपको करना है integration, and then after you will obtain one last term, and that will be f of z terms. So hope you all understood the theory very well, and if you understood very well, then the examples will be easiest for you to understand. Okay, so guys, let's start with the examples now. And here first question is given: find the analytic function f of z equals to u plus iv if u equals to x cube minus 3xy. So as I declared in the PPT, यानी कि before the one slides, that in the equations it will be given either it will be of real parts or it will be of imaginary parts equation, right? And you can observe that here the function is given into the u form, and u यानी कि u plus iv यानी कि u, it means it will be of real parts, right? So we will apply the case 1, guys. So in the case 1, in the very first step you have to find two components, यानी कि u with respect to x, u with respect to y. So I have found here del u by del x and del u by del y. Okay, then after you have to apply second step, and in the second step you have to find f dash of z, right? So उसका formulas मैंने यहाँ पर directly लिखा है, guys, del u by del x plus I del v by del x. And as you know all this one, here you have to use CR equations, and see guys, I have written here, this one is little bit light tone, but I hope you all can see. And here I have used CR equations. So by using CR equations, it will be del u by del x minus I del u by del y. Okay, now you all having a values of this both the components. So I'm just putting its values and giving the simplification. So you will get this one term. Okay. Now you have to apply the third step. And in the third step, you have to apply, you have to put x equals to z and y equals to 0. So as you can observe here, I'm applying now x equals to z and y equals to 0. So जहाँ पे x है आपको वहाँ पे क्या लिखना है, z लिखना है. So it will be 3z square. Now y 0, so this one will be 0. यानी कि this one will be 0 guys. And again in place of x we will put z. So that will be 3iz. Okay. So now at the last and fourth step is remaining and into the fourth step I hope you all know that you have to integrate the terms, right, on both the sides. So integrating with respect to z, you will obtain one function and that will be your f of z. So this function will be now f of z form because we are converting into the integration form. So f of z equals to, अभी इसका भी आपको क्या करना है, इंटीग्रेशन करना है. So that will be 3 as it is. Z square का इंटीग्रेशन होगा z क्यूब अपॉन 3, राइट. एंड आगे z का इंटीग्रेशन होगा z स्क्वायर अपॉन 2. बाकी 3 and I keeping as it is. So this one will be your z square by 2. And as a constant you have to add c. So plus c मैंने यहाँ पे add किया है. And after the simplification you will get this one term. So this one is very easiest procedure guys. So hope you all are getting very well. Now let's start with one more new example. And the question is given, construct the analytic function whose real part is. See guys, again it's directly clarified that this one is an example of the real parts. And real parts का example है, यानी कि आपको question में क्या दिया होगा, u के form में, right? So यहाँ पे u आपको दिया है. So this is same like the first one example only. So for that first you need to find two components, u with respect to x and the y. So here I have found with respect to x as well as with respect to y. Okay. And now in the second step you have to apply f dash z. So I'm going to find here f dash of z, and as you know all that will be del u by del x plus I del v by del x, right? And by using these here conditions you will get del u by del x minus I del u by del y. So these are the common equations guys. Now no need to remind. I hope you all remember this very well now. Then next you have to apply the third step, right? That you have to put x equals to 0 and y equals to 0, sorry, x equals to z and y equals to 0. Okay, so applying these both the conditions, so we will get at the last this one. Okay, and at the last you have to apply fourth step, yani ki you have to do the integration. So I'm applying the integration on both these sides. So you may get this one term, and z square का integration होगा z cube by 3. So 3 will be removed, so it will be z cube. Then z का integration z square by 2, and 2 3s are 6, so that will be 3z square plus c. So this one will be your final answer. And hope you all are getting very well guys. Now moving forward, one more examples I have given here, and the question is given, find the analytic function w equals to u plus iv whose imaginary part is given v equals to e raised to x into the x sin y plus y into the cos y. Okay guys, let's start with its solution. So here you can see that v is given, v yani ki imaginary part is given, right? So for the imaginary part you will apply the second case, right? So in the second case you have to find as a first step del v by del x and del v by del y. Okay, so that will be with respect to we are doing x. So by multiplication rule you have to apply. So first term keeping as it is, and second term you have to do the differentiation, and same second term will be as it is, and then you have to write the first term. So I hope you all know the very well this multiplication rule, right? And then after you have to apply for the next component, yani ki with respect to y. Okay, so that same similar way we will do with respect to y form. Okay, then let's start with the step 2 now. So hope you all understood the first step very well. In the first step we have just found the v with respect to x and the y. So in the first del v by del x, it means as I said, you have to apply its multiplication rule. So into the v with respect to x, you have to differentiate the terms with respect to x. So here first one I am keeping as it is, and this first one we did the differentiation with respect to x, so it will be raised to x, and then after the second term I am keeping as it is. Now we will do of second term, and the first term will be as it is. So in the second term, this y into the cos y, uh, yani ki just a minute, I'm just highlighting. Okay, so this y into the cos y will be the 0 because we are doing with respect to x, and the differentiation of this term, yani ki x into this sin y, that will be sin y only, so the x will be 1. So here the remaining value of these equations will be raised to x into the sin y. So with the same procedure you have to apply with respect to y. So first term I am keeping as it is and doing with respect to y, right? So that will be yani ki you have to do this whole term together. Okay, so here again you have to apply a multiplication rule. So here with respect to y, yani ki x into the sin का होगा cos y, right? So that will be x into the cos y, and now here you are having two terms of y. So here you have to apply its multiplication rule. So y will be as it is, and the differentiation cos will be minus sin y. Same plus करके cos second term as it is, अभी करना है आपको first का, so that will be 1, right? So this one will be the differentiation of this first term, यानी कि first term as it is, और हमने किया है यहाँ पे second term का. Now the second term will be as it is, and we will do the first term. Okay, and as you know that will be 0, so the remaining term will be this one only. So this part is very much important, guys, because without the differentiation you can't do properly. Okay, so now moving forward for the next step. So for the next step you have to apply its f dash of z, yani ki del u by del x plus I del v by del x. And as you know that here you have to apply its CR conditions, so the main formula will be this one. अभी ये आपको याद रखना ही है गाइस कि कौन सी जगह पे कौन सा CR इक्वेशंस आएगा, ठीक है. नाउ एट द लास्ट you have to put the values of these both the functions. So I'm putting here, and then after for this third step, and as you know in the third step you have to apply the values of the x and the y, right? So in the place of x you have to put z, and in the place of y you have to put 0. So in this whole function, yani ki this whole function, I am applying x equals to z and y equals to 0. So may you will get this term, and at the last you have to integrate with respect to, yani ki as a fourth step you have to do the integration with respect to z. Then it will be the integration of z plus 1 into the e raised to z dz. So here I have applied to do the integration, here I have applied sign of the integration, yani ki this one, and here dz. So now you have to do the integration. For that you have to apply UV rule, right? That is the integration by parts. So यहाँ पे मैंने वो rule apply किया है, and this one you already have studied in 11-12 standard as well as in the first and into the second semester. Okay, so I'm not going to do in details. So this one you have to apply by the integration of parts, yani ki by using UV rule. Okay, so at the last, and as a constant you have to apply here constant, yani ki C. So at the last you will get the answer z into e raised to z plus c. So in this sessions we have conducted 3 examples of the Milne's theorem, and also we will do one more thing in these questions only, and in these questions we will find once the conjugate of the harmonic function, but that we will do in our next sessions. So till that, please do refer today's session properly, and please do the practice, so that next examples you can do more easiest way. Thank you guys. Now we'll meet on our next sessions. Thank you.